We're now going to put together all the operators we've talked about thus far in the observable class and discuss them in the context of case study ex1. And this case study is going to explore the use of a bunch of observable methods like just, from array, from callable, and so on, to create, reduce, multiply, and display big fraction objects synchronously. Keep in mind, of course, that we're headed to asynchrony, but we haven't talked about concurrency and scheduling yet, so we're going to focus just on doing synchronous operations, but it'll show off all the operators nevertheless. And as always, you can find this example in my GitHub repository, in the ex1 project, in the observable reactive folder. So we're now in the IntelliJ project for case study ex1, and let's go ahead and take a look at the ex1 file. This example shows how to use a bunch of Rx Java features to synchronously perform basic observer operations, such as the one shown there. And first thing we're going to do when we come into the main entry point into this test program is we're going to register several test methods with the async task barrier framework that we talked about earlier. So we're going to register test fraction multiplication sync 1, test fraction multiplication sync 2, test fraction multiplication sync 3, which ironically are all synchronous, so we don't strictly have to use this, but just getting started to be consistent. So we register all these methods, and then we go ahead and say, hey, async task barrier, go and run all these tasks, which will go off and run. They'll run synchronously. And then when we're done, we will get the results, which will tell you how many tasks completed, which should be 3, if all goes well. And then that just prints that we completed 3 tasks. So just for kicks, we'll run it. And you can see, we'll look at the results in more detail later, but you can see we completed 3 tests. So all went well. And we'll come back here and look at the results after we've looked at the code. So let's go to look at the code. Let's go take a look at Observable EX, which is the observable example class. And you can see here that we have 3 methods defined, starting with test fraction multiplication sync 1. And the first thing we do is we make ourselves a little string builder to keep the results in one place so we can print them nicely at the end. And then we use the just operator, the factor method called just, to generate a stream of big fraction objects with one consistent numerator and different denominators. We then use the doOnNext action operator to log the contents of the computation, saying what thread they're running in. And we're going to log them as a big mixed string. Then we're going to go ahead and use the map transforming operator to take each of those big fractions and multiply them by some big reduced fraction, which is just that, so it's rather big. And then we're going to take that stream of results that have now been transformed, and we're going to use the blocking subscribe terminal operator. Remember, the blocking subscribe terminal operator does 2 things. It sets everything else in motion, so all those other operations begin to run. And it also provides these consumer and runnable lambdas to print the results or do something with the results. So here's what happens. If everything goes well and we ended up multiplying the big fractions that are generated by just by the big reduced fraction constant, then we're going to go ahead and take the result and append it to the string builder as a mixed string. If something goes wrong, we append the error message into the string builder and then display it. And if all goes well, we just display the results. And the last thing we do is we return a constant called s_void_c, which is a completed completable. What the heck is a completed completable? Well, if you recall with Java's completable futures, we had this way of being able to complete a future, if you remember that. That was one of the things you had to do. You had to complete a future that would be 0. So the concept of a completed asynchronous thing is already been understood. So in Rx Java, there's something called a completable, which does not provide a value. It just provides an indication that something is complete. And so we say, I want a completable called s_void_c for s_void completable, and I want it to be given a completed completable. And then that indicates to the task barrier, async task barrier framework, that all the processing is done at that point, and so we don't have to consider this thing any further. We don't have to wait any further for this thing to finish. OK, so that was the test fraction multiplication sync 1 method. Let's go take a look at test fraction multiplication sync 2, which is similar. It starts out by making a string builder, but then it differs by making a list of big fractions. So we use the list of factor method operator to make a list of big fractions, which is the big fraction list. And then we use the from iterable operator to generate a stream of big fractions. So we use from iterable, take our big fraction list to make ourselves an observable stream of big fractions. We use the do on next action operator to log the contents of that computation that we got from the from iterable factor method. Then we use the map method, the transforming operator, to multiply by the s-reduced big fraction. And then we do the same exact thing with blocking subscribe, which sets the wheels in motion and then prints out the results, handling errors if they happen, which they won't in this case, and then handling the completion, which it will happen in this case. And once again, we return s void c to say, hey, async task barrier, we're all finished. Don't wait for us. We're done. The third and final method in the ex1 case study is also very similar. The only real difference is a couple things. First, we're going to make ourselves a random number generator, which you'll see how that gets used in a second. And then secondly, we're going to go ahead and make ourselves a big fraction array. So before, you recall, we made a big fraction list. Now we use a big fraction array where we just make an array of big fractions which have the same numerators and denominators as before. And then we're going to do some fun stuff here. We're going to come down and we're going to make ourselves an observable of big fractions called O1, which will be generating an array, or sorry, generating an observable from the big fraction array. And then we're going to go ahead and we're going to make another observable called O2, and that's going to be created by taking from callable and calling make big fraction and generating the big fraction n times, which in this case is 4. And so you'll see that we're going to end up with an observable of big fractions. And this is the use of the lazy from callable operator, which will call this thing multiple times. And so we'll generate many times. And then the last thing we do here, which is really cool, is we're going to use the merge with combining operator to take O1 and O2 and merge them together. So now we have a single observable that's merged. And then we're going to go ahead and log the contents of the computation. And do on next, as you can see, is going to be called back every time this succeeds. So this is basically an operator that will have a callback semantic. That'll log it. Then we go ahead and multiply it using map, just like we did before. And then we use blocking subscribe, just like we did before. So the only real difference here was that we used an array instead of a list. And we also created two observables, one using from callable and repeat, and the other using from array. And then we merged the two of those things together. So let's go ahead and take a look at the results here. And you can see here that this is what it prints. And it always tells you the thread in which the computation ran. So you can see that we have it running in thread 1. It's always running in thread 1 because we're not using any async operations yet at this point. So you can see that these are the results we got from test fraction multiplication sync. And then this is the results. These are the intermediate results that we logged. You can see for test multiplication sync 2, we end up with essentially the same results at the bottom, but we just get to them a slightly bit differently. And then test fraction multiplication 3, you can see that we do a bunch more different things. And in this particular case, we end up with the original elements from the array plus the ones that we generated from the use of the random number generator and the from callable lazy factor method. So that's the overview of case study ex1.